Hello everybody. Today we're going to do chain rule. Woo. Alright, so this is one of the most powerful things we're going to be learning in derivatives, and it permeates every aspect of derivatives. Chain rule is not an option, chain rule is a thing that happens. So before, when we would try to take the derivative of this first one, it says f of x is equal to 2x plus 5, the quantity squared. The way we would handle that is we'd FOIL it out, simplify it, and then take the derivative. But what chain rule lets us do is it lets us just think about it as if it were just an x squared. So if this were just an x squared, the way the derivative would work is a 2 would come out front and it'd go down to the first power, and the x would just stay in x. So in this case, though, the x was 2x plus 5. So in the same way that the 2 comes out front, changes to a 1, this does the same thing, but the inside stays the same. And the reason we call it the chain rule is it's almost like a chain reaction gets set off, because we took the derivative, but now the inside of this also has a derivative. The derivative of the inside is 2x. Is 2x plus 5, the derivative of that is 2. So times 2. And so we could clean this up and we could say the derivative of this is 4 times 2x plus 5. And that's usually how I will leave them. So like example B, it says 2x plus 5 cubed. So the process is the same. The 3 comes out front, it's to the second power, and the inside doesn't change. Then we multiply by the derivative of the inside. And so that's how all of these are going to work here. So example C, with our 2x plus 5 to the sixth, when we take that derivative, we'll have a 6 out front, we'll get our 2x plus 5 to the fifth times the derivative of our inside, which is 2. And then our very last one, D, the first one that actually is remotely complicated, square root of 2x plus 5 is f of x. So with this one, to take the derivative of this, we need to remember that this is actually 2x plus 5 to the 1/2 power. And so when we take the derivative of that, we'll have a 1/2 out front, get our 2x plus 5 to the negative 1/2, then times the derivative of our inside, which is 2. So, oh hey, the 1/2 and the 2 are going to cancel each other out. That's nice. So in the final answer of this, I could say 1 over the square root of 2x plus 5. Remember that the negative 1/2 brings it down to the bottom. So that's kind of the introduction. Again, I've said this in class before, I try to do things a little bit differently than they are in the notes so that you can get 2 different exposures to how to think about this. I want to give you a lot of different options and a lot of different ways to think about it. So the only one from the bottom that we really need to talk about, so we've essentially done this one and we've done this one. This one right here, instead of looking at it as top and bottom, and we could do quotient rule or something, a much simpler way to handle this is to rethink about this and rewrite it as this is just 2x minus 5 to the negative second power. And so when we take the derivative of that, we'll bring the negative 2 out front, get 2x minus 5, and then subtract 1 from that exponent, and then multiply by the derivative of the inside. And a great question was raised in class when we were talking about this. Do we always multiply it by 2? And the answer is no. That 2 is coming from the derivative of the inside. Notice how basically every single one of these so far has been a 2x plus 5. Oh, this one's 2x minus 5, but it doesn't change it. So they've all had a derivative of 2. We're about to switch that up and not do that for every single example. So to finish this up, the negative 2 and the 2, that's a negative 4. And then we could say that's all over 2x minus 5 to the third. And remember, we're not allowed to leave negative exponents in our answer. That's why I'm going through and doing that final step. So All right, then we get to number 5. Now the thing is right. So if you see this and you go, oh, I can do quotient rule, you're right. Quotient rule says do the derivative of the top first, so that's a 0. Leave the bottom alone. Minus derivative of the bottom, which is 4. Leave the top alone. All over the bottom squared. With a little bit of cleaning up, that's a 0. We wind up getting negative 4 over 4x minus 3 quantity squared. Chain rule. I'm going to do this like the slow motion version, and then I'm going to do how I would actually do it to show you how chain rule is better in this situation. So chain rule says, well, I could think about this as 4x minus 3 all to the negative first power. So then I could multiply by a negative 1 out front, and then there's going to be a 4 that pops out at the end. So a negative 1 parentheses 4x minus 3 to the negative 2 times the derivative of the inside, which is 4. So I could say negative 4 over 4x minus 3 all squared. So same answer, 2 ways to it. Personally, I would be going, oh, this is the negative 1, so I'm going to multiply by 4 in the end, but it's going to be a negative 4 because it's a negative 1, and I just kind of jump to the answer. It's patterns that when you've done enough of these, you get to a point where you can kind of skip some of the steps in the patterns. Same thing, I'll do 6 the way that I would actually do it first. So I know it's going to be a negative 9 and then a 6x minus 2 on top, and then a 3x squared minus 2x plus 1 to the 4th on the bottom. So that's how I would jump to the answer, but to kind of break it down and handle it the way that we've been talking about it, I would go, oh, this is actually 3 times 3x squared minus 2x plus 1 quantity cubed, but it's the negative third since it's on the bottom. So when I take the derivative of this, I'll get negative 9, and then 3x squared minus 2x plus 1 all to the negative 4th, because we're subtracting 1, and then multiply that by the derivative of the inside, which is a 6x minus 2. So, but then I got to reflip it, and so you'll see that's where my denominator comes from. We don't flip the negative 9 because it doesn't have the exponent. We don't flip the 6x minus 2 because it doesn't have the exponent. So there's a bunch of ways to think about this, to skip steps, to rush through, and depending on your level of comfortability, skipping steps is really good on these. So 7, let's see, we're starting with 7 minus 4x squared all to the 2/3. So if I'm careful and just follow, I go, oh, I've got something to the 2/3. So it's going to be 2/3, 7 minus 4x squared on the inside. Subtract 1 from that, we're going to get negative 1/3. Just trying to make sure it's still visible. A little bit of my flashlight could be more visible. Okay. So then, multiply by the derivative of the inside, 7 to 0, and then negative 4 and x squared, that's going to be negative 8x. So when I'm trying to clean this up, remember that it's 2 over 3, and it's this over 1, and it's this over 1. Like, these are all kind of separate fractions. There's one top and one bottom. So we could say the 2's on top, the 3's on the bottom. The 7 minus 4x squared to the 1/3 is on the bottom, and the negative 8x is on top. So I would leave it here. You could absolutely get negative 16x up here. Like, you could absolutely go through and do something like that, but you don't need to. All right, number 8. Let's see, 8 says, why don't I just move it out of the way? Okay. 8 says, is this in the way? Oh my goodness. Max was like, can you keep using it? And I was like, yeah, sure. But I have to be careful. so let's see. Oop, already did that question. Sorry, something flashed across my phone screen. It was warning me about how I'm currently charging and filming, and I was like, what? So I didn't get a chance to see what it said though, because I'm not looking at the screen. Sorry about the pause. Okay, so anyway, it says f of x is -5 root x squared minus 4x plus 1. So remember, this is really just saying all of this to the 1/2. So when I take the derivative, it's like 5x to the 1/2. So I'll just say we'll multiply by the 1/2, which is 5/2. Then we've got our x squared minus 4x plus 1, all to the subtract 1 from the exponent. Then multiply that by the derivative of the inside, which is 2x minus 4. And then we clean it up by dropping this to the bottom. And then that can stay up here. Remember, we don't need to clean up the algebra, and as some of you have learned the hard way, sometimes cleaning up the algebra is actually bad because we make silly mistakes and get wrong answers when we used to be right. So the next one says -2 over the 4th root of 6x minus 1. That's the 1/4 power, so I can rewrite this as -2 times 6x minus 1 to the -1/4 since it's downstairs. And then when I go through and multiply, I'll get -1/4 times -2. It's +2/4. So that's 1/2. 6x minus 1 to the, we're going to subtract 1 from that, which is 4 over 4, and get -5/4. Multiply by the derivative of the inside, which is 6. Hey, 6 times 1/2 is 3. So final answer I would get for this is 3 over 6x minus 1. Oop, let me move up. 6x minus 1 to the 5/4. All right. So that's the chain rule. There's nothing new to do for the rest of this lesson. So for the rest of this lesson, it really is just application of the chain rule. So I look at this, and I could FOIL this all the way out and then distribute the x squared. Don't. It'd be really bad. So what we could do is instead treat this like it's two things times each other. And two things times each other means that we're going to have to do product rule, right? X squared times all this. So the way I do product rules, I take the first derivative first. I don't know why people prefer to do the second derivative first. And then I leave the 2x minus 3 to the 4th power alone. Then we do plus, and I'm going to do the second derivative second, and leave the first one alone. So the second derivative would be bring the 4 out front, leave the 2x minus 3 to the and then to the third, then times the derivative of the inside, which is 2. So that's the derivative of this piece. Then times that, leave that alone, times x squared. And you may go, this looks really ugly. Okay, well, yeah, we could clean this up. And I'm actually going to show you a technique they like to do on the AP exam for cleaning stuff up like this. So let's see, I could say 4 and 2 and x squared, that's 8x squared. So you might see, oh, they both have a 2 and an x that I could pull out, but there's actually significantly more that we could pull out of this. And this is a type of factoring you might not be used to. These both have a 2x minus 3, but they have multiple 2x minus 3s. This has 4 of them, this has 3 of them. So I could actually say 2x, pull out a 2x minus 3 to the 3rd power. Look at what's left. I have a 2x minus 3 left. Over here, all the 2x minus 3's go away, and we're just left with a plus 4x. And so because of that, we could simplify this down to saying 2, or simplify the factoring down to 6x minus 3. So on the AP exam, they'll definitely give us stuff like this, where then we have to do some strategic factoring out. So just be wary of that. All right, number 11. 11 says f of x is equal to x root 4 minus x squared. Oh, hey, it's two things times together again. So we could say, take the derivative of the first one, so f prime, the derivative of the first one is just 1, leave the 4 minus x squared in the square root. Now, the derivative of the second one, if we kind of think about that on its own, well, that's 4 minus x squared to the 1/2, so its derivative is going to be 1/2 times 4 minus x squared to the negative 1/2, then times negative 2x, because the derivative of the inside is negative 2x. So we do that, and I just drop that in with that. So to do product rule, we say do the first derivative, leave the second one alone, then do the second derivative, leave the first one alone. So it's going to be x and that together. Hey, the 1/2 and the negative 2, there's a lot of things, boom, 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 all happening together. I could say this is x, and then another x, so x squared, and the 1/2 and the 2. So I could just say this is negative x squared over the square root of 4 minus x squared. So how's the AP exam going to clean this one up? Because they also like to clean these up sometimes. What they'll do is they'll get a common denominator, and a common denominator for one like this. So I should back up. In the previous question, like this first step here, that's correct. But then finding this on a multiple choice test, it looked like that. So then here, this is correct. I will accept that. That's 100% correct. But let's talk about what would happen. So on the AP test, they'll write the answer like this. So if we look at our common denominator, this is over 1. This one is over that square root. So we'll need to multiply this one by 4 minus x squared over 4 minus x squared, square root. And you'll notice on the top, those square roots cancel. And we wind up getting 4 minus x squared all over the square root of 4 minus x squared. And so your final answer for this, let's say 4 minus 2x squared over the square root of 4 minus x squared. That would be, you might see that. They might take the 2 out. They might mess with the top a little bit more to get it in standard form. So maybe they'll take a negative 2 out front of the top and get x squared minus 2 on top, and then have our 4 minus x squared. Little algebraic tricks throughout the mess. So in terms of new content, 12 to 15, there's nothing new. When I'm doing chain rule, or when I'm doing derivatives, I'm really focusing on the most outward piece. So if I'm looking at this one, it says 2x minus 1 over 2x plus 1 all to the 5th power. I'm really thinking, oh, all to the 5th power. And so I ask myself, hey, what do I do with something to the 5th power? And we just say, oh, well, the way we do something to the 5th power is we put the pen in the way. Let's try it again. We'd get 5 times 2x minus 1, 2x plus 1 to the 4th power. That's like the main derivative. But then I have to multiplied by the derivative of the inside. Derivative of the inside. Oh, it's just that. Oh wait, that's two things divided by each other. Oh, the only way to do the derivative of two things divided by each other is quotient rule. So we'll do quotient rule. Derivative of the top is 2, the bottom stays alone. Minus derivative of the bottom is 2, the top stays the same. Why did I say alone before? All over the bottom squared. Now this, I definitely could see them cleaning this up. So I could see them not cleaning this up as well. This is how I prefer to leave this. I don't feel a need to do any more work. But just in the interest of kind of clarity and going through different strategies. So this is, we could look at this as the top to the fourth and the bottom to the fourth. And in the top on this one, that's a what, 4x plus 2 minus 4x, and then another plus 2. So it winds up just being a 4. And then a 2x plus 1 squared. So we could do a little bit of cleaning here, and we could write this as 20 times 2x minus 1 to the fourth all over 2x plus 1 to the sixth power. So not 100% sure if they would want to do that on the AP exam, but they could. So unless I made a silly mistake somewhere, I think that's right. Okay, let's see, what's next? Oh, good, 13. So we look at 13 and we go, oh, how do we do this? What's the biggest derivative? What's like the biggest piece? I see an x squared, but it's inside of a square root. Oh, I see a square root. Oh, but that's inside of a fraction. Oh, so the fraction's the biggest thing because that's not inside of anything else. So then we'll just do quotient rule. And I'm saying that like it's simple. So let's see. Derivative of the top is 1. Let's draw an arrow instead of equals because I'm changing this now into f prime. So derivative of the top is 1. Leave the bottom alone. X squared minus 1. Minus derivative of the bottom. Woo! All right, let's pause on that. All over the bottom squared. Remember that a square root squared just turns into the insides, but all right, derivative of the bottom. Let's see, I'm gonna think about it over here. This is x squared minus 1 to the 1/2. So notice how I'm not thinking about it as it's to the negative 1/2, because when we do quotient rule, we just are thinking about the top and bottom normally. We're not doing any flipping or anything weird. So the derivative here would be what? 1/2 times the insides, subtract 1, then multiply by 2x. So the 2 and the 1/2 will cancel. So we'll have an x over the square root of x squared minus 1. Okay. Oh, and there's another x there. So we're going to wind up having x squared over the square root of x squared minus 1. Okay. This, while correct, is not an acceptable answer because of the square root in the denominator. That's not what I meant to say. Because of the fraction inside the fraction. We're not supposed to end with fractions on fractions. So, little trick for cleaning it up is we multiply each term by that denominator. You multiply it by each term's numerator. So here it cancels, and we're left with just a minus x squared. Here, it actually turns into x squared minus 1 because the two square roots cancel each other out. And then here, we wind up having x squared minus 1 because of the squared and the square root canceling times the square root of x squared minus 1. So final answer, you could cancel these two and get -1 over x squared minus 1 root x squared minus 1. You could even divide out the negative and get 1 over. And so when we divide this by a negative, that would change to negative, that would change to positive, and get 1 minus x squared. Square root x squared minus 1. So this, all three of these are acceptable final answers. That's a very weird thing that happens in 13 though. Common, but weird. Okay, let's check out 14. 14 just looks so pleasant. I'm going to start a new piece of paper. So 14 says f of x is equal to the square root of x over 4x minus 1. So it's a square root. That means it's really just to the 1/2 power. So that'd be 1/2 times x over 4x minus 1 to the negative 1/2 power. I got a trick for you on this in a minute. And then we're going to multiply that by the derivative of the inside. Gee, that sounds great. Derivative of the inside, oh, we got to do quotient rules. So that's going to be 1, leave the second one alone, minus derivative of the bottom is 4, leave the first one alone, all over 4x minus 1 quantity squared. You might be going, this is so terrible, and then I'm going to have a fraction inside of a fraction. But wait. To the negative 1/2. Negative exponents literally mean reciprocal, like we flip it upside down. Normally we don't start with a fraction. So like if I had negative 1/2, why am I saying negative 1/2? If I had regular, let's say 3/4 there. If we had 3/4 to the negative second power, instead of saying this is 1 over 3/4 squared, which is true, we could also say this is just 4/3 squared. And if you don't believe me that they're the same, 4 squared is 16, 3 squared is 9, so 16 over 9. This is going to be 1 over 9 over 16. And remember that 1 over something literally means 1 divided by it. So 1 divided by 9 over 16. And divide means times by the reciprocal. So it's the same thing. So here, instead of saying 1/2 and then having to put this whole fraction in the denominator, I'm going to say 1/2, flip it. And then, I really don't feel like doing that. Oh, wow, that's so not bad. It's negative 1. And then 4x minus 1 squared. Ooh, bad. Forgot the 1/2 power there. Okay. So I'm going to leave this here. You could pull the negative out here and like do a little cleaning, but nothing, no fancy tricks beyond that flip. We are almost done. 15. So 15, we could do a couple different ways. One way to do it would be quotient rule, even though you might not see that at first glance. So, actually, there's a lot of different things we could do to play with this one, but I'm not going to do any of those. I'm just gonna do it as we see it. So that negative 3 means we could flip this to the bottom and do a quotient rule on it. But let's just do it as we see it. So f prime. Bring the negative 3 out front, x squared minus 4 to the negative 4 times 2x, because the inside says x squared minus 4. Leave the second one alone, right? We took the first derivative, left the second one alone. So for something like this, it might actually be helpful for you to go, okay, first derivative, leave the second one alone. Then find it and then plug it in. because I don't know if you heard it in the tone of my voice as I was doing this, but I actually forgot about the second one for a second, so I forgot what I was doing. So it might be helpful to like leave it blank, leave the second one alone, and then plus leave the first one alone, and then find the derivative of the second one. So that might be a helpful way to make sure we don't forget any parts. So here, second one, let's see, there's a 3 out front of x squared plus 4 to the 2, then times 2x. So I'm looking here and I'm like, there's definitely something I'm gonna be able to pull out of everything. But let me do a little bit of cleanup first. So here I got negative 6x outside of x squared minus 4 to the negative 4. And then an x squared plus 4 to the 3. And on this one, I have a positive 6x outside of x squared minus 4 to the negative 3, and a x squared plus 4 squared. So it looks like I can take an x squared minus 4 to the negative 3 out of everything. I can take a 6x out of everything. So again, well, we need to flip those two, but flipping those two, we're at our final answer. I'm going to do the more secretive methods now. Looks like we can take an x squared plus 4 squared out of everything. So if I do that, then what we're left with is negative x squared minus 4 to the negative 1. And here, we're left with a spoopy. So we could flip that one, get a common denominator, do some more stuff. Definitely could do more stuff here. Not sure how far they'd go on the AP test for something like this. But that would need to get flipped to the bottom, and that would need to get flipped to the bottom either way. All right, 16. All right. H of x is equal to f of x cubed. So it wants us to find h prime of 2. I don't care. I'm going to find h prime first. Before I start thinking about what numbers are going to be, I'm just going to find h prime of x. Well, the way that we do these derivatives is I look farthest out and I see, oh, it's something cubed. So I do it like I normally would. I say, oh, 3 stuff to the 2, and it just stays the same. But then we multiply by the derivative of the inside. And the derivative of the inside is super difficult. What's the derivative of f? Oh, f prime. So it's literally going to be 3 parentheses squared times f prime, and that's just it just stays f. And then it says h prime of 2, and so anywhere I see an x, I can put a 2. And then I just have to be careful and follow directions. It says take 3, multiply that by f of 2 squared. Well, what's f of 2? I go look at it tells me f of 2 is negative 3. It tells me f prime of 2 is 6. It tells me g of 2 is 3. It tells me that's a g. G prime of 2 is negative 2. For some reason, it also tells me that f prime of 3 is equal to 4, and g prime of negative 3 is equal to negative 1. We're going to see what happens with those in a couple minutes. So let's say it says 3, and then f of 2, that's negative 3, squared times f prime of 2, which is 6. So if you must know, we can get a number here. 3 times negative 3 squared is 9 times 6. So it's 27, and times 6, that should be, what, 128? That feels wrong. No, it's 108. No, what is it? 9 times 6 is 54. Oh, I was doing times 2 in my head. Yeah, it should be... hold on. This is 3 times... Let's see, 3, 18, so 9, plus 72. Wow, it's a lot bigger than I thought it was. Okay. So 6 times 27, that's 42, 12, 4. Really? No. That's not right. It's 184. No, 42. Oh my goodness. That's 12. So then 16. 162. Hey, how about we just... Okay, all right. Only took me 4 hours. All right, so I got 162. Let's see, number 17. 17 says the quantity f of x minus g of x to the second power. So if we're going to find this derivative, it's something squared. So we'll say take that thing that's squared, bring it into the 1 power, times 2 out front, leave the insides alone, and then we'll multiply this by the derivative of the inside. Derivative of the inside, well, it's two things subtract each other, so it's just their separate derivatives. So that's going to be f prime. That's going to be g prime. And now it's literally just going and making sure we put things in the correct spots, because all the x's are turning into 2's now. Let's see, f of 2 is negative 3. G of 2 is 3. F prime of 2 is 6. G prime of 2 is negative 2. So that's going to be plus 2. It's a negative 6. That's an 8. It's negative 48 times 2. I got negative 96. All right. (18) square root of 4g of x minus x minus 1. Okay. So the big derivative to take here is it's to the 1/2 power. So then when I take the derivative, I'll get 1/2 times 4g of x minus 1 all to the negative 1/2 power, multiplied by the derivative of the inside, which, so the derivative of the inside, that's going to be 4g prime minus 1. Remember, derivative of 1 is 0, so we're done. And now I'll just plug in my 2's. So let's see. I see, well, the 1/2 stays. G of 2 is 3. X is 2. And then G prime of 2 is negative 2. It's minus 1. Okay. So then, what is that? 1/2, 12, 13, 14, 15. Oh, no. 12, 10, 9 to the negative 1/2. Negative 8, negative 9, so negative 9. Okay. So, I'd say this is 1/2 times 1 over the square root of 9, which is 3, times negative 9. So I could rewrite this as 9 over 3 is 3, so negative 3/2. Three more. All right. All right, these are the weird ones, but once you get it, they're really easy. So, what's my biggest, my most outside thing? My most outside thing is f of x, right? That's just on the inside. So what's the derivative of f of x? F prime. So we'll write f prime of x. Oh wait, no, not f of x. This goes in the middle. Hey, what's the derivative of the inside? G prime. So it's weird looking, but that's what happened. That's the abstraction. So now we got to be really careful. Let's leave the f prime where it is. That says g of 2, and g of 2 was 3. And then g prime of 2 was -2. Oh, sorry, this is number 19. So then it says f prime of 3. Oh, and that might be why they told us that f prime of 3 a little bit earlier was 4. So this turns into 4 times -2. Then we get -8. So on to number 20. 20 says g of f of x. So when we take this derivative, well, the most outside thing this time is g. So we'll say g prime, leave the insides alone. And then chain rule happens, and we have to multiply by the derivative of the inside, which is just f prime. And so the same thing happens now. We leave the outside alone. Let's see, g prime of f of 2. Well, f of 2 is -3. And then f prime of 2 is 6. Which I'm just getting by looking at the numbers they gave me. I'm not doing any special stuff here. Oh, then it says g prime of -3, which they gave us. It's -1. Turns into a -1 times 6, which is -6 for our answer. And the final one that we have here is f of -f of x, which is very strange looking. But check it out. Just start on the outside. So the derivative of the outside is f prime. So we'll write f prime of, leave the insides alone, -f of x, times the derivative of the inside, which is just -f prime of x. Oh. And now we have to carefully go inside and plug stuff in. So the outside's not doing anything yet. F prime, leave it alone. F of 2. F of 2 says -3. So -3, which turns into +3. And then times -f prime of 2, which is 6. So times -6. And then f prime of 3 is 4. 4 times -6, which is -24. Okay. Those are all the different techniques that there are for derivatives. Chain rule, and then product and quotient rule, and power rule. Beyond that, we have some special formulas we learned. Like we can't do any derivatives right now if it has trig, or e to the x, or ln of x. We're going to learn all those soon too. But they're just new formulas, and we bring them into the same old ideas that we have now. So I hope this has been helpful. I am sorry that I've been kind of humdrumming my videos recently. I've been fighting colds and just a little bit more stress than I wish I had, but I hope it's helpful. You know where to find me if you have any questions, so feel free to reach out anytime. Bye!